Okay, so we're going to talk about a geometric series. Okay, so we have talked a little bit about the summation notation before. So what I'm going to do, it's the sum as n goes from 1. We'll do from 1 to 10. Let's say, I'm making up numbers. 3, my kids yelled out, oh, they said 5 and 7 in first period, I think. But anyway, I already wrote down the 3. 3 times 7 to the n minus 1. So you'll notice, if you see this, this is a geometric. You remember arithmetic looks linear and geometric looks exponential. Okay, so if I were to expand this out, the first term would be 3 times 7 to the, well, 1 minus 1 is 0, so just 3, plus 3 times 7 to the first, plus 3 times 7 to the second, plus then the last one I would get to would be when I plug in 10. 10 minus 1 is 9, plus 3 times 7 to the ninth, if I were to expand this out. So if you think about it, this is a ridiculously large number, and I'm going to add these all up. I expect my answer to be very big. But I don't want to do all these and then grab a calculator. I mean, we only have 10 terms, but imagine if we had 100. So what we are going to use is we're going to use the formula. Then this is the formula for a finite geometric series, and that's equal to a sub 1 times 1 minus r to the n over 1 minus r, or sometimes it's written a sub 1 times r to the n minus 1 over r minus 1. This, we just factored out a negative and they canceled, and it got us here. I tend to use this one. There's no real good reason why I picked that over that, but that's just my natural inclination. So on this one, in our series, our first term was equal to, well, this is gone, so that's just 3. Or it's not gone, it's 1. 1 times 3 is 3. Our common ratio we found was we were multiplying by 7, and our number of terms was 10. So we can use that formula. I pick this one. If you write it every time, you won't have to worry about memorizing it. So the sum of 10 terms is going to be equal to 3 times 1 minus 7 to the 10 over 1 minus 7. And here, yes, I would give you a calculator. So, hang on, let me just make my life cleaner. So it was, I forgot, it was 3 times, and then I like to put this 1 minus 7 raised to the 10 over 1 minus 7. And sure enough, it's a big number. So this is equal to 1, 4, 1, 2, 3, 7, 6, 2, 4. Lovely. Okay, notice if I wanted to, like, sure, you could argue, I can plug in 10 numbers, Miss Kosh, that's great. But if I had made you raise this to the 100th power, or excuse me, not raise it to the 100th power, but find the 100 terms, well, good luck with that. We definitely have better things to do with our life. Now, another thing, if you haven't watched the little cartoon that I posted on the calendar, this is a great time to go watch that. It's a ridiculous little cartoon. No, the math is fantastic. It's a little cheesy, so embrace the cheese and then just watch it. But they talk a lot about infinite. I can't spell. There we go. They talk about infinite series, and so the idea is what happens if I'm taking the sum as n goes from 1 to infinity. Okay, and so if it's something, in the video they talk about this one right here, which would be 2 plus 4 plus 6 plus 8 plus, and it keeps going. These get bigger and bigger and bigger. The only thing the video said that equals infinity. I don't like that notation. What we're going to say here is that this sum, if we're going to sum something, we want to get a number as an answer. So I would say, since there's not a number, a particular number as an answer, we're going to say that it does not exist. Okay, so the sum as n goes from 1 to infinity of 2n does not exist. And they also use the word that this one diverges. Okay, the only thing that we study in pre-cal, the only infinite series that we study in pre-cal that converges is a geometric infinite series whenever r is less than 1. So like if I had something like 64 plus 32 plus 16 plus 8 plus 4 plus, notice my numbers are getting smaller and smaller. If they get bigger and bigger and bigger, it's going to diverge and go off to infinity. This one would converge, and it would settle in on a particular value. So if we think of this one and put it in summation notation, this is the sum as n goes from 1 to infinity of 64 times, notice this was half each time, 1/2 raised to the n minus 1. I just made something up. And so we have a formula. Well, I need some space to write it. I'm going to write it over here. We have a formula, an infinite geometric series. And that is S. Sometimes I'm lazy and I don't put the infinity. I know Mr. Loach likes to. It doesn't matter. A sub 1 over 1 minus r. The sum of an infinite geometric series is A sub 1 over 1 minus r, assuming that the series is getting smaller. In order for it to get smaller, r has to be less than 1. The absolute value of r has to be less than 1. Okay, so coming back over here, A sub 1, the very first term was 64. See there, it's 64. Our r value is 1/2. And so if we want to figure out what this series converges to, and by the way, notice, if I say 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, I'm already getting close. That's 127 with just those whole numbers. So we know we're going to be at least 127. So on this one, the sum is equal to A sub 1 over 1 minus r. That's equal to, in this particular case, 64 divided by 1 minus 1/2. I should have gotten another piece of paper, but I didn't. 1 minus 1/2 is 1/2. So if I multiply by 2 over 2, that cleans up the bottom, and I get 128. And so the sum of this particular infinite geometric series is equal to 128. Okay, hope that's helpful.